Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is DB2 Environment Awareness for Platform, Operating System and Middleware Administrators. Our guest speaker today is Ms. Ashwini Ramani, Information Architect and Lead DBA at IBM. Ashwini is an IBM Certified Advanced DB2 DBA for LUW and she is also a Certified Cognos BI Administrator. She has 6 years of experience as a database administrator where she has supported databases like DB2, Oracle and SQL Server. She has conducted many DB2 DBA training, mentoring sessions for large audience in India, China and Philippines. She also has versatile skills and experience on the various databases and data warehousing tools. Ashwini is currently performing the role of a solution architect for information management. So without further delay, I introduce you all to our guest speaker. Over to you, Ms. Ashwini.
A very good evening to all of you. I'm Ashwini Ramani. Welcome to this webinar for the topic of DB2 Environment Awareness for Platform, Operating System and Middleware Administrators. This session is basically targeted for all type of audience. It could be beginners, it could be database administrators, not specific to DB2 database alone, but databases of other RDBMS as well. Also primarily useful for administrators who manage operating systems and middleware. The idea behind such a topic was most of us have expertise in our respective technologies. However, it is very useful to have some kind of an overlap knowledge of the areas that surround our technology. Let me take you through the agenda for today's topic. Moving on to slide number 2. We'll go through some of these points of what is a DB2 solution lifecycle, what are the typical DB2 platforms. Many of them get confused as to what is DB2, how does it behave on Linux systems, how does it behave on mainframe systems. So I'll give you an overview about the various DB2 platforms. What are the important considerations for a DB2 environment? Because most of the times we only talk about a database on a system, but there are a lot of other things to it, like what is the platform on which it runs, what are the middleware that it is interacting with. So I'll take you through some of those considerations. Most importantly, what is the type of data and what is the load that is sitting on the database? Example of a typical problem scenario. A good understanding of what is the front end and back end for a DB2 environment. And lastly, about the insight and approach to handle databases from the perspective of an administrator and who can be a platform and operating system administrator, or from the perspective of a middleware administrator. Moving on to slide number 3. I'm aware that we have an audience who's a very right blend of developers, project managers, probably administrators, and who are DBAs or maybe OS administrators. So all of us go through something called as a solution lifecycle, where we start with a design phase. We first gather the requirements, we understand what are the requirements, we work on a design, probably we work on a configuration or a development, and then we go on to implementing it, probably testing it, and then we go on to maintain the environment. We look at optimizing it over a period of time, and if required, we look at upgrading the environment. So the picture that you see on this slide is specific to a database environment, where we start with designing the DBMS. We look at configuring it with the hardware, the OS, and with the platform, and then we go on to implement the database with databases, tables, and the objects of a database. The next thing is maintenance of a database, which is a key for any DBA. Then we look at optimizing the database from best practice point of view, and of Of course, we have upgrades across versions or upgrades of fixed packs and so on. But some things to be noted are not everything is technical in a solution. There is a lot of other planning, there is a lot of capacity planning, a lot of thought process that goes into designing a solution. So most of the times, designing a solution is a teamwork of a specialist and an architect. So it's not something that can be done by one person. There's a lot of thinking that goes into it, which is always a teamwork. When you look at a typical database administrator, there are two scenarios. One is the scenario where we support an existing environment. I guess the DBAs in this audience would be aware that we have application DBAs and system DBAs, or rather physical DBAs and logical DBAs. So what does this mean is most of the times the logical DBAs or the application DBAs work with the application developers in understanding the application, what is the requirement. They work on to design the database. But there is another area which is called as the physical DBA, or the actual DBA who goes on into the implementation phase of the database, who works on maintaining and supporting the databases. We have another scenario where we are looking at solutioning a new environment, where we don't restrict that role as a DBA. We rather call them as architects who look at from the time of planning the solution, who look at what could be the capacity of this system, what could be the future scalability of this system, and things like that. So let's take a look at what are the good and bad of both these scenarios. Moving on to slide number 4. The scenario is supporting an existing environment. The primary focus areas in this case is to how best to run the environment. Most of the DBAs, or rather administrators who are supporting production systems, or maybe dev test systems, look at how best they can manage the system. They look at technical skill building, where they look at the new features, probably look at what are the enhancements that they can come up with. Their key focus is to establish SME contacts in that area. So their scope areas is typically looking at tuning and optimization, automation, like I said, enhancements, and derive best practices out of their experience and document it and provide tangible results. But there are some gray areas, because most of the times as DBAs, when we have performance issues or when we go through severe issues, we know that there are a lot of things that we can fix, but there are few things that we cannot change, which is like the design of the database. Although we can still go back and try to change the design of the database, we know how much of a big deal it is to actually go back and try to make an impact over there. Also, the product selection is not in our control, because for experience guys, we know that probably this database works best on this platform, or probably AIX works best with DB2, or it could be anything. So that way we cannot do anything at that point of time, because the product selection has already happened and you're just managing an existing environment. Also, there is no exposure to the business layer here, because the business guys usually talk at the business level. So when you're managing a system, you're only looking at the technical aspects of it. You only see how to fix the problem and how to maintain it, but you have no clue about how to get into the business layer of it. So in this case, again, say if I'm a DBA of a particular database, I know that I have this database, I might know the host name, I may know the port number, I may have details about the user IDs and things like that, but I may or may not know to what all other interfaces my database is talking to. So the architecture here is somewhere unknown and unexplored. So what we have observed is the approach is slightly more confined in this case. Moving on to slide number 5. So this is a second scenario where we are looking at solutioning a new DB2 environment. So in this case, we start with something like a functional requirement. So for example, how much of RAM is required, how much of CPU is required. So these are requirements which are required to functionally run the system, or which are required for the functional working of the particular solution. There are some of the non-functional requirements which include costing, performance, availability, and so on. So the focus area here is rather consulting. Some of the scope areas here is platform. So we need to have good understanding of what is the hardware that is used, what is the operating system we are loading on it, storage and backup, very, very important. Some of the areas like capacity planning and scalability. So here, when you design a solution, it becomes the responsibility of the consultant or the architect. It becomes the responsibility of the consultant or the architect to actually make sure that. Am I audible?
disturbance from your end, Ashwini.
Okay, I'll continue. Sorry for. Can you hear me?
There's some disturbance from your end.
I guess it should be fine now. Can you hear me?
No. Yeah, it's fine now.
Okay, so you're connecting me back?
Yeah.
Okay, thank you. Am I audible?
Ashwini.
Okay, am I audible?
Yeah, you are audible. You can start now.
Okay, okay, thank you. So sorry for the interruption. I'll continue with where I stopped. We were looking into slide number 5, a second scenario where we are looking at solutioning a new DB2 environment. So in this case, some of the scope areas for us would be to understand the underlying hardware and operating systems, the storage and backup, capacity planning and scalability. So importance of this is we need to arrive at building a solution in such a way that 10 years down the line it is still valid. Not after a year where we look at and say, it's not the right solution and we try to scrap off the whole thing and try to rebuild the solution. So that's not the idea of a good solution. So that is where we look into some of the aspects of capacity planning and scalability as well. And one of the best advantages here is the product selection, because based on experience without exhibiting a product loyalty, we have a freedom of choosing the right product with the right platform and right environment. Also, of course, depending on how much of funding and licensing you can afford. So how does it help here? We have a thorough exposure to the business layer. We have an understanding of the overall architecture, and this way we get an idea of the various behavior of products on various platforms. So that gives us a broader picture of the whole environment, thus helping us to manage the solution. Moving on to slide number 6. So this is a table which gives you an idea about, it's the simplest categorization of DB2 for various platforms. You see 3 rows over here. The first row is IBM System X, which we call as the X series, where we can load Windows, Linux or VMware or Solaris. These are just examples. You could have more than these as well. The second row is IBM Power Systems, which consists of the P series and IBM I, where we load AIX and Linux. So these two are the categories which are called as DB2 for LUW, where LUW stands for Linux, Unix and Windows. So for DBAs who are mainframe DB2 DBAs, that's the last line that's in there. So this is where we have IBM Systems Z series. So the mainframe category of operating systems are loaded here. And that is where the architecture of DB2 differs over here, where we call it as DB2 for ZOS. So it's not, both are not the same. DB2 for LUW has a different architecture as compared to DB2 for mainframes or ZOS. Moving on to slide number 7. So here is a list of considerations for a DB2 environment. So before you actually go ahead and try to install DB2 on a system and get started with setting up an environment, please take a look at some of these which are very, very crucial for functioning from a functional perspective. The first thing that you need to remember is whether to choose a physical system or a virtual system. So when we say physical or virtual, what it means is a system going to be a LPAR or a VM image, which is a virtualized system, or can be hosted on a physical system? Am I audible, Mohini?
Yes, you are.
Okay, thank you. So the reason why a physical or a virtual system preference is important is because When you plan to have a big setup, something like maybe a replication or maybe an HADR environment, it's very important to have a background of what kind of hardware or what kind of a system you use over here, because a VM may not have sufficient capacity, or it may not have sufficient resources to actually host an advanced setup. So in that case, you may opt for a physical system, or it's up to your environment depending on what requirements you get. But this is a very important consideration before you actually go ahead and start implementing your environment. Physical location of the system is very, very crucial, because the network speed matters based on the physical location of the system, and who are the audience who are accessing the system. Based on that, please keep this as an important consideration. Memory, of course, there is no real ideal value of a memory or paging space, because depends fully on the requirement on the applications. So I'll be dealing with some of the type of load in the coming slides, but memory is something that you need to have a right balance of. If you plan to have some of the heavy loaded applications in your front end, make sure you have sufficient memory, because many a times we have seen issues where the operating system runs out of memory, but we actually try to tune a query trying to solve the problem. So that is the reason why such a presentation we've come up with, because these are some factors which a lot of us learn after spending a lot of efforts and experience on this. But it would be helpful for a lot of people who have already not been through something like this, but very valid points which will help them use as good references. So coming back to the considerations, kernel parameter is very important, especially for those guys who worked on Linux environments. If you have not tuned your kernel parameters correctly, you will notice that you have a lot of shared segment errors while trying to start DB2, or maybe your system may not perform optimally. So DB2 has a good documentation of how much tuning is required, the percentage of kernel parameter tuning that is required as compared to your OS memory. So kernel parameter is an important consideration. The number of processors is again an OS level configuration, which is again important while planning your system. File system sizing is very helpful. I'll cover this a little in detail in the coming slides. Product behavior is another consideration. A practical example that I can give you is we had a case where we had loaded DB2 on Linux, which was running on P series. Although it is compatible, we noticed that the performance was really not up to the mark. But the same thing when we moved the system to DB2 on Linux on X series or AIX on P series, the behavior was much better and it was performing much well. Of course, there could be other aspects to it, but understanding the product behavior is very important while suggesting a new solution. Software packages and libraries, we had a recent issue last week where we were not able to install a product because some package at OS level, an RPM package, was missing, and it was not even mentioned as a prerequisite in one of the documentation, but still we realized that not having that one particular package can really not support the whole application. Lastly, integration with other application and system is very important. Like I was saying, you need to know to what interface your database is talking to. You need to know what are the other things which are dependent on DB2 and what are the other things on which DB2 is dependent on. Moving on to slide number 8. So I was talking about having type of data and load on DB2. There are two types of data and load that DB2 can handle. I guess a lot of industry experts know it already. We have OLTP and OLAP environments. So how does it matter from a database end? When you consider an OLTP scenario, it is a database which is prone to several transactions per day, and the system needs to be up to date. So that means you're going to have a lot of insert, update, deletes happening with consistency and concurrency supported. You need to have data which is non-integrated and most likely application oriented. So the best example that we can look at here is a railway reservation system or any of our retail counters. So we see that there are a lot of transactions happening almost real time. So for example, let's take the railway reservation system. So when we go up to the counter, we ask for tickets, and they'll have to check for the availability. So it also means that there are a lot of people trying to book tickets online. So which means the data has to be consistent and support concurrency, where people are accessing from all over India the same portal, and we have people supporting counters as well. So imagine the kind of load that is going on into the database at the backend. So it has to have sufficient capacity to handle this kind of a load, and the underlying design must be in such a way that it can support this kind of front end. So that's the idea of understanding what is the load that is going to come into your database. On the other hand, moving on to slide number 9, you see that there is another kind of load, which is the OLAP, which is the online analytical processing. So here we are looking at something like a data warehousing kind of an environment, which primarily holds historic data. We do not have live updates here. It's mostly batch processing that is done over here, mostly subject oriented. So for example, if you, as all of us watch cricket, we see that when there is a player walking into the field, there are a lot of statistics that are flashed on the screen about the person, about the patterns, about the history of how best this person has scored, and what can be a predictable score for this person. So for all these kind of analysis, we have an OLAP system that is somewhere running in the backend storing all the data. So these OLAP systems are widely used by reporting tools for generating reports. So understanding whether your database is going to be used by an OLAP environment or whether it is going to be used by an OLTP environment greatly helps you to manage the underlying database. Take a look at slide number 10. It shows a picture. I'll move on to slide number 11. This is just a table which gives a comparison of OLAP versus OLTP. This is for your reference, although I'll just stay on here for a minute. But the primary takeaway point from this slide is the last line, the last row, which means OLTP is primarily used for running a business and OLAP is used for managing a business. So let's take a look at a typical problem scenario. Moving on to slide number 12. You see a red arrow over there which talks about the problem area. So most of the cases what happens is we have applications running, and that's where they report the problem. So let's consider the red arrow as the problem that's being reported at the application end. So the first thing that the application guys do is to check whether there is a problem with the code or if there has been a bug or so. Moving on to slide 13. You see that a lot of times application folks come back to the database and then it's assumed that it is a problem with the database. So what the database guys do is spend a lot of time in understanding what is the query, whether it is performing well or not, what is the time it takes to do a complete table scan or a table space scan, index scan, do we need an index or can we improve the query, and all these parameters come into picture. But somewhere at a point of time, the DBAs know that it's not going to work anymore and it's not a problem with the DB. That's where we move to the middleware area, probably go and check if there is a problem with the, say, an application server or maybe a web server. Moving on to slide 15, you see that the problem arrow is now shifted to the operating system. So see, by now it is already about maybe 4 days or 5 days where the problem has been reported, and it's being passed on from application to database, database to middleware, middleware to operating system. So 90% of the cases, each of these is handled by a different team. So if I have an application team, I have a database team, I have a middleware team, I have an operating system team. So the issues get passed on to all these teams to and fro. So in our own experience, what we have seen is if somebody reports a problem, we check at the DB2 end or a database end. If we know that it's not a problem, we pass on the problem to the middleware end. The middleware folks check and pass it on back to us. So this used to happen a lot in the past, and I'm sure it still happens with a lot of teams. So finally, as you look on to slide number 16, you see that the problem is moved to the hardware layer. So the idea behind this typical problem scenario is to give you an idea of where the problem could actually lie and where we could actually be looking at. We had many live cases this way where application folks reported errors to us, and it was actually because of a problem with the hardware. Somewhere the hardware had an issue, or maybe there was a problem with a particular piece of hardware where there were the pages were not really there were dirty pages getting reported at the DB2 end. So whenever there were access to that particular table space, the database used to go down. So that is when, after a lot of analysis and after spending a lot of days and a lot of efforts, we realize that the problem is actually not with any of these layers but with the underlying hardware layer. So what we are trying to communicate over here is it's very important for every person to have some amount of multi-skills, because that helps us in knowing where all the problem could be. For a person who is confined to his own area, although there is a saying that it's good to be a master of one trade, not jack of all trades, but it's good to be master of more than one technology is what is our understanding, because that helps us in recognizing how best these products talk to each other, what are the problems that could come in each of these areas. So that's the importance of understanding the whole architecture over here, which helps us to get into the root of the problem quickly and help us solve it without wasting too much time. Moving on to slide number 17. So another important thing which is very important is as DBAs or any database administrator probably supports a project for 1 year or 2 years and moves on to another project, maybe moves on to many projects, or there are teams which manage hosting environments where we have multiple environments, multiple applications talking to DB2 or any other database. So what we try to look at here is the behavior of the database with the various front ends. For example, we have a SAP application that talks to DB2. We have a rational application that talks to DB2. How differently is DB2 behaving in front of these applications? So in our experience, we have seen that when you have SAP as a front end, the DB2 database is quite heavy with several number of table spaces and large amount of data that is going in, usually a very bulky database. But in case of a rational suite, it could be an RTC or ClearQuest. The database is usually small but prone to several transactions. So every record is really very crucial, not to be taken lightly because it's a very small database. When you look at some of the other front end like DataStage or Cognos, these are again IBM products where DataStage is an ETL tool and Cognos is a reporting tool. So DataStage is an ETL tool, if most of you know about it. So there are a lot of jobs running over here, which means there are a lot of jobs scheduled to run at that backend database. So database is heavily subjected to a load, so it's usually heavily loaded. Same thing with Cognos. Cognos is a heavy duty reporting tool which has DB2 at the backend or could have any other RDBMS. So this backend database again has to have the capacity to handle a heavy application like Cognos. So if you know the behavior of these products, it is easier to handle the database rather than just having only DB2 knowledge and looking at how we can solve the problem. So if I know that SAP is talking to DB2, there are a list of known errors with SAP with DB2 probably. There could be a list of known issues, or there could be a observed behavior of RTC with DB2 which can be easily solvable. Similarly, more importantly, understanding the backend gets even more significant because you need to have an understanding of underlying OS. Why? Because in our practical experience, what we have seen is when we support a database, we see that if a file system gets full, we have to wait for the operating system team to actually come back to us and increase space on the file system. It could potentially have an overhead that way. Also, it could be because if you have access to the box and you still do not have skills on OS, there is really no point in trying to wait for somebody to fix the problem. So when you look at operating system, there are a lot of overlap with DB2 because we have seen memory issues, we have seen CPU utilization issues. There are errors getting reported in the operating system log file about DB2 errors. So that way, a basic understanding of OS is very, very important for every DBA, and that is what we emphasize in every presentation that we do. Storage is another important thing. You need to know on what platform or on what storage your data is lying. For example, your data could be lying on hard disks. Your data could be lying on a shared network. Why this gets important is, if you know that your data is lying on a disk, you probably want to look at some kind of a RAID configuration or a mirroring where you know that your data is secure. In case a disk fails, you have parallel disks to support you. We had a case where we had a lot of databases that were configured for a particular environment, and often we used to see that there are a set of data file systems which used to disappear every other week. Now we were noticing what is wrong with this. We see that all these are mounted on SAN, and that's how we know that SAN had an issue, and that is why all these file systems were going down. So having some idea of what is the storage that is used for your data is very helpful, because as DBAs we talk about containers, table spaces. So knowing what the actual container is also very helpful, in addition to knowing just the path of the containers. Networking, some amount of networking knowledge, whether it is pinging well, whether there is a DNS issue, whether it is a host name issue. Many times we have had issues while creating an instance because the host name was not yet configured. Also, we have had issues when we move the environment to another system. Change in host name can lead to DB2 not running unless you make a change in the configuration file. Monitoring tools again is very helpful. I'll take you through this in the coming slide. But there has to be some idea about monitoring tools which can save a lot of time for you, because we have spent a lot of time on writing scripts, shell scripts for looking at health of table spaces, or a lot of other collection of system health data. But with the new monitoring tools that are coming up, for example, IBM has its monitoring solution called as the IBM Tivoli monitoring solution. So here we see that it has a lot of inbuilt capabilities to monitor DB2, which we may or may not know. So once we know it, it really saves a lot of effort for us to avoid writing large scripts and spending time on doing something that already exists as a solution. Moving on to slide number 18. So this is, although it mentions that this is for platform and operating system admins, all of these slides can be applicable to any DB2 beginner or any database administrator, not specific to DB2 alone. The first thing that is important is planning the environment, capacity planning. Always make sure you install DB2 on a different volume group or a different disk other than that of the system disk. If you know, on Windows, if you just have the C drive with your system data, it's really a risky affair, because if your system C crashes, your data is gone and there is no other way you can get it unless you have a sound backup system in place. So always we recommend you to have a separate disk or a separate volume group for the data or the database code. Plan separate file systems, one for the DB2 code. Each instance has to have its own file system. Different file systems for data, possibly on different disks. Active logs, you need to have a separate file system. Archival logs have a separate file system. Diag logs, put it on a smaller file system. Backups, depending on what backup solution you are adapting to. And one file system for your scripts and the DB work that you do. So this is not documented anywhere. There is no hard and fast rule that you have to follow this, but this is the best practice that we can give based on our experience. Size for these file systems has to be decided based on how much you can get and what is the requirement that is coming into you. Moving on to slide number 19. Some of the file systems that you see here is the code. Code is usually sitting on /opt/IBM DB2 v9.7 on AIX and similar on Linux. Home directory of instances, which looks like /home/DB2 NST1 by default. You may have your own home directories. Data, of course, you can have it, like I said, you can have it on SAN network, or you can also have it on DAS-DE or disk systems. Backup path, make sure you have at least one copy of your database backup on your local file system. Slide number 20. There are some important users and groups for DB2 which are not to be messed up with. We have had cases where it happens that a DB2 user is thought to be a normal user, and sometimes there are some changes that happen at user level. For example, maybe the user is dropped and recreated, and it looks like the user is back, but the instance is actually gone, because when we have DB2 instance created, the user, every DB2 user is actually a OS user, unlike your other RDBMS, where you have a variation where it could be a OS user or it could be a DB level user. So every user in DB2 is an OS user. So some of the important users are instance user, fenced user, DAS user. These three are the mandatory users that you require to specify when you install a DB2 system. Primary groups, instance primary group, you have your fenced group and the dash group. These are three groups that you are required to specify while you are installing. Processes, if you want to have a look at what are the DB2 processes running in your system, PSEF, grep DB2. If you want to have a look at what are the active DB2 instances, just mention PSEF, grep DB2 SYSE. This is on Unix systems. Now, the idea here why these things are put here is the OS admin many a time is required to do some of the DB2 tasks while maintaining it. So, a knowledge of these could really help in knowing what is important and what is not important. Again, why we have mentioned these is when an OS admin manages a system, he is expected to clean up the system or probably take a look at what are the processes, probably take a look at what are the users. So in that case, if there is no idea with where the OS admin does not know what are the important things, it can create to a lot of havoc on the system. So it's good to have an understanding of this. Moving on to slide number 21. Many a times OS people reboot the system or we ask for a reboot of the system. So if there are maintenance activities where we have data center maintenance or any other maintenance that is going on, the first expectation is to make sure the DB2 is running after a reboot without any manual intervention. So you can adapt to either init tab approach where you set up your own script in etc init tab and give an rc.db2 file, or you can use the DB2 inbuilt utility, which is the DB2 iAuto, and you can start up, make sure that DB2 starts up automatically. You can also specify which instance has to start up automatically and which should not. You have the flexibility to do that. So if you see here, you can validate whether your instance is up and running, whether it is configured for iAuto using the command specified here. On Windows, it is pretty simple like any other application. Just go to start, run, you have your services.msc file. Just pick the service that you want it to come up automatically. Just say right click properties, and there is an option to enable automatic startup. Moving on to slide number 22. There are requirements to schedule DB2 scripts and jobs. So you can use a cron tab on a Unix system. I guess most of you already know about it. So you can use either the cron tab of the root, or you can use the cron tab at DB2 level, which could be the instance user or any other DB2 user. When you're using the cron tab of root, make sure your DB2 profile is sourced to the script. Otherwise, you may find that your job is not running, although everything looks right with the script. Many a times, it so happens that there may have been a change in the IP address or change in the host name of the system, and after that you find that your DB2 is not running anymore. This is a case where a lot of operating system admins have a problem with. So just for your information, there is a file called db2nodes.cfg, which is a configuration file which has an entry of all the partitions that the DB2 system is connected to. If it is a single partition system, it will have a single entry with a 0 node entry, and it will have the host name entered in that. So if you have had a change in the host name of your system, make sure you go there and validate whether the new host name is reflecting over there. If it is not reflecting, take a backup of this file and change the host name, save it and restart DB2, and it would work fine. Next is maintenance of log files. We have heard a lot of cases where accidentally a developer or maybe an operating system administrator, without knowing, unintentionally deletes some of the DB2 log files. These could be active log files or archival log files. We had practical cases coming to us where this has happened and the active logs have disappeared because of the simple reason that these logs are stored as .log, and anything .log which is old is probably assumed that it is not needed anymore and it is wiped off. So in this case, it becomes really a very tricky situation unless you have the latest backup. If you have a recovery time objective where you need data, which is up to date, then you really have no option but to, convince the customer to accept some amount of lag. So just to avoid this, make sure you never delete or anybody in that, that area, or those who don't know, they database administration, make sure that there are no log files that are getting deleted from DB2 end, especially the transaction log files and the archival log files. You can find something like S000 star.log as of that pattern. So if you find something of this pattern, please don't ever look at deleting them. But there are cases where the DBA would want to delete them in case of a maintenance activity. So that's very much possible. So unless asked by the DBA, it's best to leave them as is, even though they are occupying space on your system. Coming on to slide number 23. So I was talking about ITM. ITM is the inbuilt Tivoli monitoring solution for IBM system. So what you see here is it has a lot of capabilities which reduces the work of a DBA. Whatever is mentioned here, say if you want to monitor your table spaces, earlier we had to either configure your health center, or we may have to write scripts, Unix shell scripts or Perl scripts to make sure that these are monitored and the notification is sent to you. But now with ITM coming in, you can set up an agent in your client system where it can automatically monitor your table spaces and send a report to you or send the same notification to you. Also, a lot of data that we used to, a lot of time that we used to spend in collecting data, such as what is the buffer pool hit ratio, or what is the sort overflow, what are the log timeouts that have happened. All these things can be captured by ITM. But again, ITM is something that you have to buy. It's a solution that is offered by IBM. So it covers a lot of such aspects, very useful things that we have practically used in our systems. So it can just configure the agent and configure your thresholds, and it would automatically monitor everything and send it across to you in an email. Moving on to slide number 24. TSM is another IBM solution which it's called the Tivoli Storage Manager. So DB2 and TSM go hand in hand. So you can also have Oracle or any other database configured with TSM. So TSM is the backup solution that we use. Configuring DB2 with the TSM is a very simple procedure, but very useful because you can take backups directly to TSM from DB2. And it's one of the most reliable solutions that we have seen in the past, because if you have a file system, if you have a backup that is taken on the same file system, and if that system crashes, then there is no point in taking a backup. Or if you have a backup on another system and your primary system crashes, there could be a time that takes for you to get the backup image from the other system, or if there is a worst case scenario where the other system has also crashed, then that's even more weird to think of. So it's always good to have backups taken to a third-party backup agent. So here I've just jotted down some simple steps to configure DB2 with TSM and take backups. Just install the TSM API client. You have both the 32-bit and 64-bit clients, depending on what instance you're using. Just install it. You have two files called as dsm.sys and dsm.opt. Just configure these files with some information that you require from the TSM administrator. These are simple parameters such as the server name of TSM, the node name and the port number, and configure them. Make sure this is registered at the TSM end. Again, you can just interlock with the TSM administrator who can give you inputs on that. You have to configure the DB2 user profile with 3 entries of the path of where these libraries reside. Update the node password as root from DB2 end. And you will have to test the connectivity from DB2 to TSM. So the utility that we use here is the DB2 ADUTL tool. So this is used to check what are the backups available for the database, what are the log files available. It can also be used to retrieve backup images from TSM to the local system. It can also be used to verify a lot of parameters. So simple command here which can be used to directly push a backup to TSM is DB2 backup DB name, use TSM. You can also use TSM as one of the media to store your archival logs instead of maintaining them on your local file system. So all that you have to do is configure your logarc met1 parameter to TSM. But make sure before you configure this, your TSM connectivity with DB2 is intact. Else you will see a lot of errors in the DB2 dag.log where it reports that there is no connectivity established between DB2 and TSM, and you could have several errors that are logging in the DB2 dag.log. Moving on to slide number 25. This is for middleware administrators. These could be WebSphere administrators, WebLogic administrators, Java, ABAP, maybe Apache, HTTP, all these category of administrators, we call them as middleware administrators. So many times we see that they have a need to know what is a DB2 version and fixed-pack level that is installed. And just to know this information, they may wait for a DBA to come, and to avoid that lag, we can just pass on these information to them. So all that they have to do is just switch user to the DB2 instance and enter the DB2 level command. Similarly, if you want to know what are the products that are installed on the system, DB2 products installed, it's only on Unix that you can use this from version 9 onwards. It's DB2 LS. Moving on to slide number 26. For those who are administrators, who are application server administrators, we have seen that you have requirements where you need to know what is a driver type, whether it is a JDBC2 connectivity or JDBC4 type 4 connectivity. You may need to know what is the database name, what is the host name, what is the port number on which the instance is listening on to. So these are information which you can collect yourself. So if you have an idea about this, it gets you work faster. Error log files, very important for everybody on this call. So we have instance name.nfy file, which is a basic admin file which logs information about the errors. We have a db2 diag.log, which is a diagnostic log. You can control how much of information you want to log into this file. You could opt for an thing where you just need to you want it to log only critical messages, or you want even warnings, you want severe messages, or you want even information level messages. It can be controlled. And yeah, the simplest thing is we have seen a lot of errors that are coming in. Say if a VAS admin or maybe a WebLogic administrator is running an application and he finds an SQL error that is coming to him, which is a DB2 SQL error. So the best thing that you can do is just DB2 question mark the SQL error will give you an output of the documentation of the error. It will tell you what is the problem, how to solve it, and what could be your problem and some of the steps to solve the problem. About 70-75% of the times this helps. Of course, if not for this, you can always go to the information center and check for further errors or further information before you actually start Googling for the error. So checking the status of a database server, you can just say psef grep db2 sysc. db2 sysc is the process which helps you know whether the instance is running or not. And on Windows, you have the Windows services, which tells you whether the service is up or not. That's about it. I'm done with my presentation. So I have mentioned some of the references here. One is the information center. One is for the Tivoli monitoring, the ITM solution that I was talking about. And one is for backing up DB2 with TSM. Yeah, I want to acknowledge Balaraju, who is our technology architect and program manager. He's contributed a lot, and he came up with this innovative idea of such a presentation. Thanks to you. And also we took a lot of information from Redbooks, Information Center, and Data Warehousing Basics and Concepts learning materials from IBM. Thank you, everybody. Now I'm open to questions. I can take questions now, so please type in your questions.
Ashwini, I've started assigning you questions. Can you please check in the questions pane?
Sure, let me check. Okay, I have a question here. Just a minute. Okay, I have a question from Sachin Kulkarni. Can DB2 database have OLTP and OLAP data at the same time? Yeah, it depends because we have something called as an operational data store, which probably has a mix and match of the characteristics of both. You can definitely have, but if you're considering having DB2 for OLAP, you have the IBM DB2 data warehouse solution. If you plan to have it for OLTP, of course, we have our enterprise server edition. So depending on how much load you plan to put on the database, you can have the right product to choose. So when I say DB2, it's not just one product, we have DB2 server products, we have client products. DB2 Enterprise Server Edition is the most widely used product by most of them. But in addition to that, we have DB2 Advanced Enterprise Server Edition. We have DB2, other products such as Client Connect Server Edition. We have runtime clients. We have DB2 Content Manager. So DB2 is a big catalog of products. So you can pick the right solution for the right requirement. I can take the next question.
You can continue with the questions.
Okay, sure. I have a question from Vaibhav Sharma. What is the use of DB2 fence user? This is basically one of the users that is shown up when you install DB2. You have three users that are coming to you, which is the instance user, fenced user, and the dash user. Fenced user is applicable only in case of UNIX environments where you have the operating system address space concept. Hello? Okay, I'm audible, I guess. So when we talk about fenced user, we have a lot of user-defined routines, a lot of things that you may want to have within your own address space. So that is where we use the fenced user. Although a typical DBA may or may not use the fenced user in detail. If you want more information about this, you can get in touch with me offline, and I can give you an article which explains in detail about this. I can take the next question.
Continue with the questions. I've already assigned you a lot of questions.
Oh, is it? I can see only. Okay, I have one.
You just need to untop the pane. Yeah.
Yeah, just give me 1 minute. Okay. Okay, I have a question from Rambo. How do you monitor and measure each process in your solution cycle? Yes, it's a very good question. Actually, this we used to use Negio's tool earlier, and now we use our own IBM solution, which is ITM. So you can define what all you want to monitor. So we have people to do this dedicatedly, so where it monitors each process, especially when you want to monitor the CPU utilization, or when you want to monitor specific processes. For example, if you want to monitor how much your instance process is consuming CPU, it definitely reports to you whenever there is a breach of the threshold. So that's how we use our monitoring solution to measure these. Next question from Arun Gupta. What is the method of uploading Unicode data from the different platform? Is that the question? Okay, so when you're trying to load data, I'll try and answer this question if I understood the question correctly. When you try to upload data across platforms, you first have to check the compatibility of the platforms before you actually go ahead and do it. So what we do typically is we collect the infrastructure and platform details of the source and the target. We see what is the database code set and what is the territory and other stuff from the database perspective. We see if the same can be adapted to the target, and if we see there is an incompatibility that is noticed between the platforms, we try to find the best workaround to make sure we don't lose data, or if there is some level of acceptable modification of the data. I'll move on to the next question from Gaurav Kumar. What middle layer includes? Okay, so when you say middleware layer, it could be a lot of things. So just to give you a quick overview, when you say hardware, we know that it can include your disks, it can include your rack, your network cable, or probably monitors, keyboards, all these things. When we say operating system, we know it can mean AIX, Linux, Windows, VMware probably. When we say database, we all know it could be an RDBMS or any other DBMS, which could be ODBMS or hierarchical. So when we say RDBMS, we know it could be DB2, Oracle, SQL Server, Sybase. So there are a lot of other things in the middleware layer before your application actually is on top. We have something like when you enter your browser, you have something like HTTP, right? So that is nothing but a web server. So you have a web server which is running in the backend, which is an HTTP server, and that's where you're able to, that is the reason you're able to access that particular link or the portal. Similarly, you may want to host a lot of your applications. If you see websites, you will see a lot of portals, or you have portals or portlets that are running. So these are all hosted on a portal server. So similarly, you can have a lot of applications. If you have your online reservation system or any other application, they are actually developed applications which are running on top of an application server which is capable of hosting that application. So when we say middleware, it could include all of these. So it could include web servers, application servers, it could include reporting tools or data warehousing tools, depending on what, how your architecture is defined. If you want to have a separate category of data warehousing layer, you can have it. But if you're saying middleware, it could be ESB, it could be, it could be MQ, message queues, message brokers, all these. I'll quickly move on to the next question. How a two-phase commit works in DB2 from Rambo. Two-phase commit, I'm not sure what exactly you're referring to. Are you talking about the commit while loading data, or is there something else that you're referring to? Okay, in the interest of time, I think I'll get in touch with you offline. I can give you a detailed answer for that. Definitely. So I think Mohini, we can wind up the session because we're almost on time.
Well, thanks for the insightful presentation.
Unless we have more questions.
Ashwini.
Thank you.
I'm really thankful to you for conducting this webinar. It was a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of the webinar would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.
Thank you everybody for attending this session. And you can get in touch with me offline. My email ID is ashwini.ramani@in.ibm.com. Please feel free to drop in your questions. And I have a couple of questions which I can definitely answer in detail with reference to articles. Only because of the shortage of time, I just would like to take it offline. Thank you. Thank you once again. Have a great evening. Bye.
Bye.